did a search.
Good morning, good morning. Let's see if we can extend the creature logic a little bit more today. So I want to be able to start making the different modules talk to each other, but we'll see. First, I want to fix this issue. I did some changes over the weekend. While working on a video. which means that I think I uncommented something here. The question is where? Now I changed this one. That can't be it. And I changed how the points here work. Could this actually be it? Maybe. Talking about this one right here. Wonder if it's this that messes it up. Let's see. Let's just try and return static position here. We have a little bit of problem. I can't control the blobs as I used to, so let's see if we can fix that as well. Yo, what's up, Love? It's going pretty good. How about you? How about you? Let's take a quick look. Doing well, nice to hear, nice to hear. Yeah, this one. Okay, now we're back. Craft launched Subnautica 2 this weekend. Yeah, I saw. Pretty good numbers as well, right? Pretty insane. And good feedback as well, I've heard. Where it's well liked. Ah, there we go. Okay, so what I want to start with today is I think we're gonna see if we can utilize our attribute system and give the blob some energy, which is going to be the first attribute for it, and then we're going to make the jump and rotation and everything like that cost energy, and then we're going to start exploring how those two modules can communicate this. So it's basically going to be the agent brain. So we're going to have components that sends messages to the agent instance. The agent parses these and relays them to the correct system, pretty much. So it's the agent that will handle the communication. Yeah, indeed. Will you try? I would love to, but unfortunately, I don't have much time these days. It actually looks... I think I would enjoy it. It's just time problem, unfortunately. Yo, what's up, Derek? Don't have any energy for this one, right? Attributes, no, we only have weight. Okay. Yeah, since we're only doing like, we're only working, or I'm only able to work on this game 2 days a week. I think we've made some great progress with that constraint. And I really think we can get some monster simulation going by the end of this year. That might actually be called a game, but we'll see. So what I want to start doing today is, this is our graph that generates the blobs. So this is how we procedurally, or these are the rules that procedurally generates the blob. Currently this is mostly visual stuff. We have some other properties here, but not many. I want to add some nodes here to be able to add logic to the blob. So pretty much I would like to have a node that adds a action handler, I suppose. So if we take a look at animate entity. So right now we add the action handler here, like this. And for the character, we add the action handler here, just in the editor. I want to be able to add the action handler here, and then we can also define what kind of interactions or actions this monster should be able to do, and so on and so on. So that's what I want to try today. But I wonder if we might want to structure this a bit, or at least add okay. I wonder if I want to add a I want to create a placemat here, and let's say visuals. Is that a little bit too... No, it should... Just to add a little bit of a structure for future me. Something like this. So we have the visuals for the blob, the eyes within the visuals, and then we're gonna add some logic here. So creature visuals generation. Yeah, we're gonna rename this and go through it a little bit later on, because yeah, the naming needs some work. But okay, here we have our nodes. Alters, converters, functional generators. I think we're gonna add we're gonna add a folder and we're gonna call it agent. And let's duplicate. Setters, add rigid body. Yeah, let's take this one. And we're gonna name it yeah, the problem as I see it is how action handlers are currently non-mono behavior. But we instantiate it in start here, so that's probably good. A little bit word awake here. That's okay. I think we're just gonna remove this line eventually. Okay, so we're gonna want to get the animate entity, which should be added creature. Okay, we can start by adding an animate entity here, I think. And here we're currently adding the actions. This we're gonna move to the graph. Okay, great. I think we can do it like this. So, let's see here. Animate entity. I'm wondering if... yeah, let's try and do it like... let me just check this one out real quick. Body, animator, and body. Do we really need an animator? Oh well. I'm wondering, we want to add animate entity. We want to add body as well. We actually have a body for... Oh yeah, we want to add... We're gonna do animate entity editor node for now. And I want to check out our blob here currently. So what do we have? Soft body handler, which we get from the soft body node. We have creature, we have body definition. We have an animator, we have attribute handler. This I also want to add in graph eventually. Yeah, you know what? I think we're just gonna do... Yeah, fuck it. We're gonna have an add animate entity, and that's gonna control the action handler stuff for now. But eventually we will move it to a separate node. So add animate entity editor node. Okay. And then we do add animate entity runtime node. Input count 1, output count 1. We don't want to have any rigid body data. For now, this one is going to be empty. Is compatible with input index 0 needs to be game object, and output needs to be game object. And then we have our generate here. And we're gonna get the game object, and then we're gonna add some stuff to it. So it's pretty much gonna look like this. Game object dot add component animate entity. And here we're going to set the action handler to something. Okay, this is only a get right now. So yeah, we're gonna save this one up. Eventually, I am pretty sure that we're gonna make this into mono behavior again. Maybe we should do that first. Or you know what? We're gonna do it like this for now. We're not gonna add an action handler. Instead, we're gonna add a lot of actions like this. Hell yeah. So it's gonna look like this. Yo, what's up, Apukas? We are gonna do so add animate entity editor node. We're gonna send in a list. We can make it like this: game.actions.action actions. Now for gonna do each. So we just add them like this, because this means that here we're gonna have we're gonna need to do serialized reference abstract. Can we have a list here? Because what I want to add is, let's see if this is actually possible. Because what I want to is undefined actions here. We want to add an option. Is it option? Like, in a best case scenario, we would be able to add a list of actions on this node. That would be quite good. So just like we add a string here, I would like to be able to add a list of actions. Is that too much to ask? Agent or animate entity, right? Add animate entity editor node. Right now we have cashless. You wonder. Let's see what happens if we do game.actions.action list with default value null. But I don't want to change this one. We want to keep that one. Do we actually want to keep this one? No, we have it here. Okay, so let's do game.actions.action array and default is null. This might be a bit too optimistic, I reckon. We could, however, create a custom class, which I think we're gonna need to do, yes. Let's try and do this. Serializable, public struct action list. We're gonna put this somewhere else if it works. And then we're gonna have serialized reference, abstract selectable, actions, action list, and then here we do action list instead. And we just do new action list. Is it because it's a stress single one? Could work with struct. What are the constraints for visible options here? We have some nodes with pretty extensive lists. Enum, just we do actually have like game object references. Could it be that this is not enough for it to render in a graph node? That would definitely suck. What can we do instead? We could cheat it a bit, I guess. And keep it in a separate scriptable object file, but I don't like that. See how to... Actually, we're gonna do it like this. Yeah, it's Copilot, it's GitHub, but the actual model that is being used is, it varies. It's possible to show and assign virtual classes in a Unity Graph Toolkit. Does this make sense, this question? Is it possible to show and assign virtual classes in a Unity Graph Toolkit node? So assign virtual classes to a Unity Graph Toolkit node options. Let's see if it has something like this. Apukas, it's being extremely helpful actually. It has reduced the time for some tasks a lot. It's not as great like when you get down to the itty gritty in like HLSL, for instance. It's not as good, but when it comes to general gameplay logic and general Unity stuff, it has been amazing. Unity Graph Toolkit, however, is quite new, so this is a shot in the dark. I'm gonna do a Google as well. Unity Graph Toolkit, assign abstract classes is not the term I'm looking for, I think. Do options. Let's see. There we go. This is the exact question I want. Enums. No. Yeah. So I guess this is a similar problem as you have in the Unity editor. By out of the box, Unity doesn't work that well with classes implementing interfaces if you want to show like a list of interfaces. You need custom editor tools for that, which I have, and it works great in the editor. We can see here that here we have a list of classes that inherits from action, and we can display them here and have them in the same list. Looks like we're gonna have to extend the editor render script for this to work with the graph toolkit, unfortunately. Let's see. Yeah, that's just testing. Yo, what's up, CodaCube? Sounds nice. Any reason for the switch back to voxels again? Okay, so let's just assume that we can't rely on this. What approach would we like to take instead then? Yeah, it's the UI render that is the constraint, but I think we already knew that. I don't really like. What I want to avoid is like, one easy approach would be to have a scriptable object, which is a list of actions pretty much, and then we refer to that one in the node. So we drag and drop a scriptable object. That works. But I like when most of the stuff is in one place. So if, for instance, if we talk about the blob definition, I would like everything that controls how the blob works and looks should be constrained to this graph. I don't want to end up in a situation where I have 15 files that describes the blob instead of just one well-structured, mind you, graph, you know? SDFs are really inefficient if there's more than 32 of them, even on a 5070 Ti. Polymorphic is what the word I wanted to use. Let's see. I don't want to do manual factory either, I don't think, because each action has a lot of setup. We can just take a look at the character. For instance, we have so here we have the hold action for our character, and we're gonna have a lot of separate the creature hold setup isn't gonna be this detailed, but pretty much we need to define like what is the carry point, how much can it carry, if it carries something that is extremely heavy, how does it look, which animation to use, and so on and so on. And I would like to be able to define this or select this in the actual node. CodeQ, but was it really 2 weeks wasted? I mean, you did something, you created something, you learned something probably. Wasted. Let's just see, let's wing this. How would a editor solution look that makes it possible to assign polytopic classes to Okay, while this one works, we can I mean, an option would be to have it here as well, but nah, we're gonna need to assign a lot of stuff. So for instance, during the procedural generation, we're not for the blobs, mind you, but for other creatures we might generate an arm, and then we want a point on that arm, probably the palm, to be the whole carry point. So we generate a carry point here, or a hold point, and we want to be able to assign it directly to the action in question. Fuck, that's gonna be pretty hefty as well. Okay, what we could do is we could create a network of nodes where we add, so we create nodes that add actions. Maybe that's not so bad. So we have a node that is create action, and we're way more specific in create action. And then we feed it into an add action node. But that means that we're gonna have, it's gonna take up so much space. It's gonna take way much more horizontal space, where I would prefer vertical space here. Ah, fuck, this is what I talked about earlier. This is a solution I don't want to do. Yo, what's up, Scafer? Put only an object reference on the node option. Yo, what's up, Harukanen? Long time no see. This is not what I want. Okay, all of these options we have already gone through. I'll kind of be lurking here every now and then. Appreciate it, appreciate it. Yeah. Boring. Because what I would like... Okay, let's see. Let's say we do something like... Yeah, fuck it. Let's create... I want to do this as a node solution. I don't want additional data here. I want it in the nodes. So we're gonna create a... We are gonna create a... We're gonna create an add action node. We're gonna finish this one. We're just gonna add an animate entity, and then we're gonna create a add action node, and that action node is gonna be very specific, pretty much. Let's see. CodeCube, didn't you just recently build a new PC? Appreciate the 7 streak, Scafer. Yeah, we don't really have a point ladder just yet, but maybe in the future. But a personal meeting, then we're probably looking upwards to 15 stream streak at least. And non-expenses paid. Oh, you got it pre-built, CodeCube, okay. Okay, I've built one computer in my life, and I don't think I ever want to do it again. It just don't click for me, you know. Okay, add animate entity. Let's do it like this. So add an animate entity editor node. We don't have any options here. I don't think. Not right now, at least. So we just leave it like this. We don't need this. And here we want to return new add animate entity runtime node #less. And we're gonna remove this one. This one will just be empty. And then we'll remove this one. And we jump down and remove these. So it's, oops, not all of those, just these 3. And then we might as well do this. Okay, very basic node. But before we continue, I want to try it. I want to see I want to double check that it works. So we're going to remove the add animate entity in our script file. So when we spawn a creature, currently we have a lot of temporary stuff. So for instance, this one, we're going to remove this because hopefully, or we're going to do it like this. We're just going to get component if animate entity is equal to null return. Scaper, have you seen this fast script reload? Oh, I might try that one, because unfortunately it's moving quite slow these days. Yes. Okay, so let's do it like this. Oh yeah, of course. I want to add in the editor node, we want to undefined ports, rigid body editor node. We want to have one of these. And we also want to have one of these. So then we just take the game object from here and move it like this. And then we save this one. Jump over to the game and hope for the best. And we want to check blob. And we have an animate entity here, so that's beautiful. And we also have these actions we add manually. Yeah, but how is the work, like how does the Steam Deck battery switching compare to the Pizza Place? Is it more fun? Okay, so now we move on to add action. Okay, I wonder how painful this is gonna be, because I think this might work. Let's duplicate this one, and then we do add action editor node. Here we return null. Add action, and then of course I want to have options, and we're gonna try if we can do something like this now. So add option, game actions, action focus. Let's see what kind of actions we have with a lot of settings. Fuck it, let's do hold. We know that hold has a lot of options. And then we just call this one hold action. And we do... Okay, let's see if this works. So now we want to create an option for the very specific class of hold, which inherits from action. Repair shop is nice. We have a speaker in the back, and basically all of my friends work there. That sounds real nice. Yo, what's up, cutie? Let's see. Add action. Like, I really thought this would work. Hold action, system serializable, serialize field, hold definition. Cutie, is it okay to post Reddit links in the chat? Yeah, usually it is. What is this Reddit link you want to post? Escape, what system do you use for the Blob AI? If any, like FSM, BT, flowcharts, etc. It's gonna be goal oriented, and you're gonna have a set of modules that talk to each other via the main brain module, and it's gonna be like a sender-receiver pattern, pretty much. So I guess it's pretty much gonna use most of these systems you mentioned, but at different points. Like, you're gonna have systems that monitors the attributes of the blob, and then you're gonna have rules, like if one attribute goes below this or above this, send a message that this happened, and then you're gonna have other modules that listens to that and goes through their like flow of actions. Cutie, ways to earn scam money from users. What the fuck is this? Does it make sense, Scaper, what I'm saying? There's a lot of potential problems, that's for sure. But like, the idea has always been to have a very dynamic, like the creatures themselves, it's more like a simulation, you know. So there's going to be a lot of different systems working together. Like, it's definitely like, I don't like to just pick a design pattern, you know, and follow it to the T. That gets you usually to a pretty good point, but sometimes not all the way. But it's definitely gonna be a lot. It's basically a goal-oriented system at its core. So I think, I'm not going to pull it up now, but in the design document and in some in a task, we have a diagram that shows the flow. But like, think of it like this: the blob has an attribute energy. It becomes low. It sends a message to the brain that the energy is now low. The brain is going to relay this message to the module it knows handles it. That modules depend, so it's going to be like the consume module, but to be able to consume something, we need to find something to consume. So then it's going to relay the message to the search and if we find something, we're gonna relay back what we found, and so on and so on. Scaper, I think Minecraft has some brain system for the mobs. Yeah, that's like the Minecraft system for the mobs is extremely basic. We're aiming a little bit higher here. But okay, so the problem is we aren't even able to show action. I mean, hold. Why the fuck not? Yeah, you gotta have a design document for any project greater than just one file, you know. Okay, so how? Okay, this breaks everything again. Why can't we show this one? Yeah, Harukanen, that's like the movement, but don't you have... Yeah, you have like wolves that attacks other critters, don't they? So there's a little bit of logic there, I guess. Goal-oriented, but with one goal. Every few hours, eat something nearby. Yeah, VR shaders seem fun, actually. Just for that fact. What goals do villagers have? Oh yeah, you have villagers, they sleep sometimes and they flee when they get raided. Skeletons run away from dogs. Wolves, is that true? Fuck, I'm gonna use that tactic next. You can have a dog on a leash, can't you? Okay, credit where credit is due. Villagers do seem a little bit more complicated than I first thought. Makes sense, makes sense. Okay, this one boggles my mind. We can have game object, but we can't have action. I think one thing is apparent. I don't know nearly enough about Minecraft. This makes no sense. There are also villager children. Don't think I've ever run into them. Game companies are usually quite reluctant to adding children or childlike characters in games. I've seen the baby zombies though. Zombie children you definitely have. They are the worst. Latest Minecraft have baby stuff for everything. Oh shit. I've confirmed hold is serializable. What do Twitter think about Pragmata? I've only seen nice clips from that game. It seems pretty cozy. Do it need to be Unity engine object to be able? Okay. Okay. Yeah. We are gonna see. In project graph toolkit experimental. I'm wondering if this might be in the latest. Yeah. Okay, that doesn't seem... Scriptable object wrapper again. Yeah. It seems like we're more and more prone to actually use this solution. And that would be great. scriptable object for actions. Is that a good path forward? Maybe. And then we can move it later on. Yeah, I think we're gonna do it. Data. Or actually, let's put it in action. But then again, then again. Then again, we want to be able to assign stuff here. Yo, what's up, Taralis? You can check out my YouTube. You have a few clips there, how it looks, and so on and so on. Functional is relative. How about structs, by the way? Can we do this? If we can do this, then we're okay. Hold definition. Let's do hold definition. We wait there. Yeah, there's a lot of subsystems not entirely thrown together just yet. Okay, we can't do structs either. Fuck, we're pretty much held back by this experimental package currently. We could go with a very So what we could do is that we have a node, you select the enum, what type of action is this, and depending on what action we pick, we add all of these options pretty much. But then again, that's also pretty rough. honestly seems like the best option right now. I want to see Unity Graph Toolkit. Is this the latest version? March 9. Creating graphs by code. Customization. Oh, nice. Okay, this I'm gonna love. Node customization. Oh, that's beautiful. Data type customization. With the new data type style mapper, you can now modify how a type is displayed in your graph. Oh, okay. This is like visual glitter so far. Support for collections. This one I'm gonna love. Yo, this one. Okay. Okay, all of these are great changes. But okay, that update won't help us. Escape for deprecation of Graph Toolkit in 3 to 1 years. That would pretty much be the last nail in the coffin for me. Then I would probably jump ship. Then it's good old time, you know. I'm building a lot. Pretty much everything related to the monsters is tied to Graph Toolkit currently. But it's extremely enjoyable. Like, we tried to have the procedural generation set up in an object on the component initially, and that was hell on earth pretty much. CodeCube, sorry about that. A whole essay of saying how games are censoring. Oh, yeah. You should never listen to people on Twitter, honestly. Majority of them are bots, anyway. Okay, I need a new angle of attack here. It feels like we are gonna have to add we're gonna have to add so many. No, I'm pretty sure the scriptable object approach is best, except for the fact that we won't be able to But what do we need to do? Unity object. Can we? No, we can't derive it here, but I wonder what the drawbacks of doing this would be. Of course. Okay. Oh yeah, because we did this. Okay, I think what we're gonna do is we're gonna add a lot of custom logic in the node to be able to create one of these actions here. The only problem I see then, there's a lot of problems always, is... Oh no, did I fuck this up? Yeah, we did. We'll fix it with Git later on, but what can we do? My only problem as I see it is that the hold definitions, we have a list here we want to add. So we're gonna have to do yeah, we're gonna have to do something similar we did with add rigid body. Like we define these options ourselves. And maybe with the styling in the next update, we can make it a little bit prettier here. Yeah, you know what? I think that's unfortunately the way we're gonna have to go. So let's do it, and then we add them on the way, like how we need them. So add action editor node. This one is gonna be crazy. We do add option, actions dot type, here. Sure, we do it like this. And then we have fuck, that's also true. We're gonna have like 4 different movement actions. So I guess we're gonna have to select that as well. That means we're gonna need to have action component, and here we have none, and then we have rigid body, action move rigid body. This also feels now we're defining it in 2 places pretty much. Did I not? Or did I change the wrong one? Add action component, action component. Yeah, and then we have moved rigid body. And the problem here now is that we're gonna have we're gonna have this and we're gonna have this. Escape for WoW, almost 1 minute ad. Yeah, there's a lot of ads. Like my setup for ads on Twitch is I have the least amount of ads but to make it so that I don't have pre-roll ads. We're gonna have it like this. And then we're gonna have action component, and this is gonna be crazy. Congratulations, Cody Cube, by the way. Good thing in Edge, you can pop out the small player above the chat and unmute it while muting the big ad player. Oh, nice. That's a little bit of a hack. Is Edge good? So the problem here is action move rigid body. We haven't cleaned this one up, but a lot of these options are gonna be decided by, or are gonna be inputs. Rotation time range, rotation max degrees, rotation jump multiplier range. Yeah. Rotation angle error tolerance. And eventually all of these are going to be multiplied by an attribute as well. What I would like to have is, I would like to have this as a struct, because then we can define it here and then we can reuse it in the graph toolkit. But if we have it as a struct, we're not going to get individual inputs for them. So we're gonna have to, maybe we can actually, there's probably some smart way we can do it, but Skiffer, do you use coroutines in Unity? Yeah, but way less than I used to. They are mono-behavior dependent, right? I.e. a object that instantiates a coroutine needs to inherit from mono-behavior. And I'm moving away, like a lot of my components, I'm switching away from mono-behavior, because I want to be a little bit careful with the amount of mono-behavior objects on that my different entities utilizes. So I've started moving it towards, I don't remember what the name is, but you have something very similar in C#. Okay, we can try and do... Like, this one is shaping up to be the biggest file in my game if we're gonna go through with this. Unfortunately. So we would pretty much need to add input ports for all of these here. Can't you cancel a coroutine in Godot? That feels like... That feels like that's something that's really needed, I think. Because if you have a coroutine, like, states can change during the coroutine. I guess you just have to exit them or cancel them from the coroutine itself. So nothing external can cancel it, but you can exit early if a state has changed. Okay. I guess that's one way to force some sort of style. CodeCube, that's usually how it goes. Okay, let's start by adding... Let's start by adding... Move... Still wondering if this is the best way. Okay, can we do this? Add action. We're gonna wait with that one. Add input port. I guess... This is also prohibited. Oh, that actually works. Okay, great. Great, 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 great. So then we could do... Add animate entity editor node. Add output port. Let's just do action handler. Yeah, we're experimenting a bit here. So we have 2 output ports. We need to handle this one. I don't know if this... Yeah, that's probably how we do it. Slice or... yeah, appreciate you asking, CodeCube. You don't need to reverse engineer it since it's open source. Body anchor. I thought we had... Yeah, we have dynamic mesh generator. Runtime node. I just want to see how we solve. Yeah, we do it like this. Yeah, that's okay. And then we do it like that. Okay. Yeah, you can port it. It's okay. And good luck. Okay, something like this. And then in add action node, where do we have it? Add action editor node. We're gonna have this one. Our first input port is gonna be the action handler. Okay. So we have one input that is the action handler, and we have one input that is... No. So this one, yeah, then we're gonna add a lot of different inputs here, depending on what action component we have. And then we have add output port. In add output port, however, yeah, here we're gonna have action handler as well. So we input an action handler and we output an action handler. Will this work? I'm actually starting to think that the scriptable object approach is the way to go here. Because this is going to be way too much work. The only problem I see, however, is and we're going to have to do some. So when we want to assign we're going to have to do a lot of searching pretty much to get the hold points and stuff like that instead of assigning them in the graph. Which is unfortunate. Yeah, you know what? Action list. Maybe this is the best way to do it. Not exactly like this, but we do it like this. We're gonna have to implement some sort of search system then, I guess. So what I'm talking about is how do we assign anchor point not anchor point count. Oh, is that so? All definitions. Target holdable. Yeah, we do get it from body. Okay, this is pretty good actually. This is pretty good. This we can assign in the graph. But then if we do it like that, we have some sort of split. Like half of the hold definition is over here in this component, or the other half is in that component. Sure, we can do it like that. One sec, be right back real quick. Okay, back. Sorry about that. Okay, so this is a pretty good setup. I think we're gonna do... I think the best approach is to just have it in creature definition. And instead of having types like this, or... yes, specify it like... this. We're gonna have game.actions.action here. Yes. It has been quite a lot of back and forth here, but I think this is where we're gonna end up. Great job, CodeCube. Hopefully you don't implement anymore. And then we do creature blob definition. Do we have an error? Oh yeah, we're gonna, so these are temporary solutions. We're gonna remove them for now. Let's clear that one, jump to this definition, and yeah, we need serialize reference here. So serialize field doesn't cut it when we're doing this, so instead we need, where do we have it? We have it in action handler. We need serialize reference and abstract selectable. Yeah, we're gonna create copies here later on. Serialize reference, abstract selectable. I'm gonna wait with that one. Let's see. Or what we need is actually action move rigid body. So this is the instance. We want a definition of it pretty much. Or setup, I suppose. So we're gonna have public struct action move rigid body data, or setup. We're gonna have rotation time range. So what we want to define here is the limits. So pretty much all, we're going to define the smallest amount of rotation time a blob can have, and the quickest, or the fastest, the smallest rotation time a blob can have, and the biggest rotation time a blob can have. And then we're gonna let the real attributes control like where we are. So for instance, a blob that has a high agility attribute will be more towards the quick rotation time, while a blob that has a very low agility attribute will be more towards the slow one. And since these attributes change a lot depending on energy, saturation, and so on and so on, we're going to use them to calculate like as soon as we start doing a jump, we're gonna fetch the attribute and get the value here pretty much from this one. So rotation max degrees 80. This one is also going to be range. Rotation max degrees range. Rotation jump multiply range 0.52. Yeah, this one. Yeah, we keep it here. Rotation angle error tolerance. Error tolerance is probably also going to be a range, but this one is going to be based on, I guess, intelligence, you would say. Or a mix between intelligence and agility. It pretty much controls how precise the rotation is. So, I don't know, a stupid blob might over-rotate or under-rotate more often than a smart blob, right? I'm actually looking forward a lot to get these attributes working here as well. So let's do range. And we have distance. So this is the same 3 time post time max distance. Are we using max distance, by the way? Yeah. So distance error tolerance. Let's add range to all of these. Movement time range. Range. And let's see, max degrees. Apex height. Max for, I think we don't use include gravity, pre-jump. Timer, current time limit. Max distance, max force. We not. Move time. Okay, yeah, that explains it. Something like this. Action move rigid body setup. We're gonna have public action move rigid body. Action move rigid body setup. No. This dot setup is equal to setup. And then I wonder if instantiate dependencies, instantiate specifics. Yeah, we do that from the controller. And then I want actually we want these. Let's keep them around for now. but eventually we're going to remove them and replace them with some calculations here. Private action move setup, there we go. I wonder if I want to extend my range here. Yeah, we're gonna do it. We're gonna have something called attribute range. Which is pretty much just an attribute definition with attribute. It should be, oh yeah, scripts, attributes. Because when we define these ranges, they are going to be paired with attributes, but we're going to pair them with multiple attributes. Or we might keep it simple. So rotation time range, agility, strength, also strength, and then we have intelligence and agility. How would the calculation be exactly here? I guess we're gonna multiply it, but that might... Now, for something that has two attributes, I think we can do... We calculate this one on the first attribute and this one on the second attribute, and then we take the middle of those two. I'm pretty sure. I think we're gonna have attribute or attribute. We're gonna have one struct for multiple attributes and one for single, so we don't need to do too many, so we don't add too much complexity to the single ones. Let's see here, attribute range, stat. Attribute based stat. I'm gonna do attribute based values. And we're gonna have a attribute based value. I'm gonna duplicate. You know what? Let's keep them in the same file. Attribute based value. We're gonna have serialized field. Private attribute, definition attribute. And we're gonna have private attribute, range, base value range. And then we're gonna have public float value. And then we do the problem is we have something called local range here. Yeah, that's true. We want this to be relative to the local value bounds and not the global ones. So if we take a attribute like strength, we do normalized values, so 0 is the lowest and 1 is the highest. But then we have, so per creature has their own bounds, so maybe a blob can only have between 0.2 and 0.4 strength. And when we get the attributes eventually, it's gonna be, so we're gonna define it like attribute here, and then we're gonna have attribute instance. Body attributes. Yeah, we definitely don't want to use the global bounce. But I don't think we have defined... I don't think we have defined yet the bounds for the blobs, which we probably need to do here. Or in the body. Do we actually have... I need to go back to the design document, but it seems like we have 3 bounds to take into account. We have the global attribute bound, which is like that's per attribute definition. That's like how low or how high this specific attribute can be. Then we have entity type based bounds. So for instance, blob entities can only have between this and this of this attribute. And then finally we have the monster instance bounds. So the instance of this monster can only have between these two, no matter how much, I don't know, you exercise it. It can never get higher than this. Or actually, it's the current one, so you can make it better. Oh, there's gonna be a lot of bounds. But the bounds per the attribute definition. Let's add general. Yeah, I have no idea. We're gonna get to that one later on. 0 and 1. Okay, so we have these bounds, and then we're gonna have to have a creature-specific bound. And then a creature instance-specific bound. So what I'm getting at is, do we need it in attribute instance? We have the global bound here. That's good. We're probably gonna call it attribute bounds. Because when I'm talking about attribute-based value, we want to take the local bounds. Okay, we can, for now, because I want to see if we can make this work, we're gonna do lerp value by local bounds. So it's gonna be this one. Value change. Local normalized value. So we're pretty much gonna do this. Calculate value. Is gonna be attribute instance dot local normalized value, and then we're gonna do base value range dot lerp. So for instance, let's say we have blobs. They use a attribute strength, which has a global or a attribute bound by 0 and 1. But blobs are a little bit on the weaker side when it comes to all monsters, so they can only have a strength between 0.2 and 0.5. And then in this specific case, we spawn a blob that is extremely weak, so it has a attribute range of 0.2 and 0.3. So on good days, when it's hydrated and saturated and whatnot, then it has a strength value of 0.3, and that's what we get here. Then. So this attribute, it's gonna maybe be jump time or whatever. All blobs have. Which makes me think that we're actually, it's not the local normalized value here, it's the blob. Yeah, the specific blob value, we get that for free pretty much. It's going to be handled in the attribute. So we just do this local normalized value. Base value range, and then of course I want to have system serializable public class attribute multiple base value. Attribute multiple based value. And here we're gonna have serialized field attributes, and then we have base value range. It's not. It's not. I don't think this is how I want to calculate it. Or maybe it is. Maybe, yeah, it is. We want to take the medium. So if it has a high agility but low intelligence, it's gonna end up somewhere in between. Yeah, so something like this. The only problem now, as I see it, is this, but then we're gonna use a system attribute handler. We have attributes. We have attribute user. Yeah, this we want to redefine a little bit, but we want to make the initial connection pretty much to the attribute. The attributes are located in the attribute handler. Maybe we don't need to keep a reference to the attribute instance. It would be pretty nice, I think. So we pretty much want to assign all attribute instances to whatever are going to use it. I think we want to do a pull. So in action, we instantiate with host or owner is probably a better word for it. Yeah, I think this is instantiate specifics. I think we're gonna have we're gonna make it virtual for now. Instantiate attribute dependencies. And we want to send in we actually have access to the host. So instantiate specifics, instantiate dependencies. Perfect. This is pretty much where we want to assign all of these or create these. Let's see. Okay. Attribute base value. We have attribute base value range. Okay, we want to have a definition in the scriptable object. And then we want to create instances. Which means that I want to split this up again. We're going to have attribute-based value, and then I guess it's going to be a attribute-based value instance. So we can do it like this. Public class. But this one can be a struct, however. Oh, I think both of them can be structs. Public class, attribute-based value. I'm gonna go instance. Let's make it a struct. We have the attribute and we have the base value range. And then we skip all of this. And then in here we have attribute-based value. Yeah, definition. Oops. So then we do base value, yeah. And we do the same up here. I wonder. Cube, thank you as always for dropping by, appreciate it. And good luck. Good luck with the work. I wonder if we can simplify this a bit. The instances we definitely want to have split up, but I think we can make this one. I think we can make it like this: attributes and one range. It's gonna fuck it up here actually. So let's go with multiple. We do it like this. And then we're gonna have a function here. So we're gonna have public attribute. No. Yeah, attribute based value instance. Create instance. And we know. Nah, we're gonna send in attribute handler here, I think. And then we're gonna do a lot of search, but attribute based value instance definition this. Let's create a constructor then. And we have attribute instance. So what we do here is I want to be able to. We're gonna do this. If attribute handler as attribute contains, don't we have anything for this? Get value or default. Can't we do if is the syntax? Okay, for now I think we can do this. Attribute instance get attribute instance or dot get attribute if attribute instance is equal to null, then we're just going to return now. You know what? Let's do an error. What is it? Yeah. Otherwise, we return attribute value instance with this and attribute instance, and that's all we need, I think. Yeah. Action, move, rigid body, and then we're gonna change all of these to attribute based value. This one is gonna be multiple later on. But we start with this attribute based value, action, move, rigid body setup. And then we replace I want to keep these for the values. I want to copy them. Action, movie, rigid body setup, yes. And then we have private. Attribute based value instance. Rotation time. Rotation max degrees. Yeah, let's do this. Rotation jump. Oops. Force multiplier. Yeah. Rotation angle error tolerance. I want to put the move related stuff. Nah, I want to put it here. Movement time, movement. Max distance. Error tolerance. Then we have movement pre-time and movement post time. So we have all of these, and it's gonna look a little bit uglier here. We're gonna do dot value on all of these instead. Rotation time. Oh, why don't... Oops. Yo, what's up, GDs? Use. Oh, yeah, of course. What did we have previously here? T angle. Yeah. Okay, let's wait here. Let's go through it. Rotation max degrees. Value. Rotation max degrees value. And for this one, we're gonna change this one. What's new? What's new? Few things, I think. How about you? We have been working on monster logic for the past today's stream and the previous stream, which is pretty exciting. But there's a few changes that needs to be made to make these different systems talk to each other, to make it a little bit less painful, you know. We're just gonna call this one R. We do time. T angle. Yeah, of course. Here we're gonna do rotation time. We are gonna do. We're gonna multiply math f dot inverse lerp between 0 and rotation max degrees dot value times rotation time. 0 rotation max degrees value and T angle. Float. Oh yeah. Float value. UGUI. UGUI. Is that the? Which one of all the UI systems is that one? Okay, so now we use rotation time. We use rotation max degrees. We use rotation jump force multiplier. We're actually going to call this one angle, T angle, float, rotation, T, or T rotation. Because I think rotation jump force multiply, here we take this one and we multiply it with rotation jump force multiplier value. Wasn't it called that? Rotation jump force multiplier. What? Oh yeah, we have it here. So I guess we're just gonna take this one, remove this. The current unit is standard. Oh, okay. Fuck, I'm gonna have to run now. But we're gonna continue this tomorrow. And we're going to see the attributes in action, because now we're actually going to fetch the attributes and base the movement on the attributes for the blob. But yeah, unfortunately I'm going to have to leave on a little bit of a cliffhanger here. Thank you so much for watching, everybody. I appreciate it. Hopefully I will see you tomorrow. Have a great rest of this beautiful Monday. Peace.